Welcome to the screencast of 3.3 Properties of Logarithms. So keep in mind this is one section where you won't have a calculator. You also need to make sure you memorize the properties of logarithms. Alright, so these should be ingrained in your head. I expect you to know them. Alright, so notice that the product property literally, when you add, when you multiply, things are getting bigger. That's the way I think of it in my head. So if I'm multiplying, if I have log base b of xy, that's going to be the same thing as adding log base b of x plus log base b of y. When you divide, you get smaller. When you subtract, you get smaller. So I think of log base b of x over y, right, as the same thing as log base b of x minus log base b of y. And then the power property, this one's pretty cool. Literally, you take the power and you can bring it right out front of the log. Okay, so there's really only 3 properties you have to memorize. You have to know, and you know, this stuff isn't new. This is from Algebra 2, so no worries at all. All right, also just keep in mind when we say log, this really means, if it's just log plain, it means log base 10. So that should be a little bit of help. All right, so example 1, express each logarithm in terms of log 2 and log 3. Okay, so we are going to rewrite log 96 in terms of 2 and 3. Okay, so I want it in the factors of 2 and 3. So let's take 96 and let's find all the factors. Okay, so clearly I see 1 right away is 2. 2 and 48. And then I can do 2 and 24. Okay, 2 and 12. Ooh, 2 and 6. 2 and 3. Okay. Wow, this is a little crazy. So 1, 2, 3, 4. Okay, so this is 2 to the 5th. So that's equal to 32. And then I have a 3 to the 1st. And that's literally equal to 3. So I'm going to rewrite log 96 in terms of log 2 and log 3. Okay, so first off, let's rewrite this as log of 2 to the 5th times 3. Because 2 to the 5th times 3 is literally going to equal 96. Okay, using rules of logarithms, I know that this is going to be the same thing as log of 2 to the 5th plus log of 3. And then we can use the power property, bring that power of 5 out front. So then I have 5 log 2 plus log of 3. And that's it. We rewrote it in terms of log 2 and log 3. All right, let's try the next one. Go ahead, you probably have a good idea of what this is going to look like, but I know 32 is 2 to the 5th, and 9 is just 3 squared. All right, so let's use the log quotient property. So this is the same thing as log 2 to the 5th minus log 3 squared. And now we're going to use the product property and bring the exponents out front. So this is going to be 5 log 2 minus 2 log 3. And that's it. We have it in terms of 2 and 3. All right, and then example 2 is we want to actually evaluate each logarithm. All right, so this looks nasty. This looks really rough. So let's see if we can, I don't know, figure out a better way to rewrite it. So first off, square root of 32. That's not a nice square number, but what I do know is I could rewrite this by saying the square root of 2 to the 5th, because 32 is 2 to the 5th. Okay, so this is the same thing as saying 2 to the 5 seconds, right? So that's just a rational exponent. All right, square root is the same thing as putting it to the 1/2 power. Okay, so, and I want it in terms of 2, right? Because it's a base 2. Awesome. So I can have log base 2 of 2 to the 5 seconds, I can use the rule of exponent, the product, oh my god, the power property. Bring that guy out front. So now I have 5 seconds, log base 2 of 2. Well, log 2 of 2, okay, so let's see. So 2 to the y is equal to 2. Well, clearly y is going to equal 1. So it's going to be 5 seconds times 1, which is going to give me an answer of 5 seconds. Also, you could use one of the rules we learned about, where if you have log base of b, oh my god, log base b of b, well, that part's going to cancel it. It's going to cancel each other out. Cool? All right, you can go ahead, pause the video anytime, try these out. So let's see, I have a base 7, so I would like to rewrite this guy in terms of 7. Okay, so square root of 49, let's see, 6 root of square root 49, same thing as the 6 root of 7 squared. This is going to be the same thing as 7 to the 2 over 6, which is 7 to the 1/3. Okay, bring it back down here, so 3 times log base 7 times 7 to the 1/3. Let's go ahead and use that power property. Bring the 1/3 to the front. So I have 3 times my 1/3 log base 7 times 7. All right, so that 7 and 7 will cancel out. I'll be left with 3 times 1/3, which is just going to be equal to 1. Not too bad, not too bad. See, it looks deceptively hard, but just breaking it down step by step, that is going to be your best friend. And now we get to some nice parts. So take the power, bring it out front. 3 times 4 is 12. ln of e minus, well, 2 times 2 is 4. ln of e. And don't forget, if I'm taking natural log, that's literally, right? So ln is literally log base e. And if it's natural log of e, I'll be having log base e of e. What the heck? This stuff cancels out, so these go away. I have 12 minus 4. That's just going to equal 8. All right, and then expand each logarithm. So, all right here, this is a lot of multiplication. So what I was doing before, well, I guess it's not too bad. It's not too different. So I want to rewrite this. I just want to expand it as much as I can. So I know when I multiply, right, the log of whatever I'm multiplying, I'm just going to be adding them. So I have log base 2 of 4 plus log base 2 of m squared plus log base 2 of n to the 5th. Let's use our rule of exponents. Well, we're getting a little ahead of myself. Let's fix this first. Log base 2 of 4, so 2 to what power equals 4. Right, so log base 2 of 4 means 2 to what power equals 4. Well, this is just going to be 2. Plus, okay, so bring the product to the front. Oh my god, bring the power to the front. So 2 log base 2 of m plus 5 log base 2 of n. And then that's it. That's our whole answer. We just wanted to expand this out fully. Not too bad. All right, so let's go to example B. So this one's going to be a little more difficult because not only do we have product, but it's like we have a division, and then on the numerator and denominator, it's both a product. So wowzer. So there's going to be 5 distinct terms, right? So I have a 2, an x, a y squared, a 5, and a z. So I'm going to have 5 terms. Okay, so let's rewrite out the top. So I have log 2 plus log x plus log y squared. And then I'm going to be minusing, minusing the bottom, because all of this on top minus all the stuff on bottom. Because when you're dividing, it's like you're subtracting the log 5 that's on the bottom. And you're also subtracting, well, here, I have the subtraction right here, so I'll distribute that out. Log of square root of z. Okay, so let's simplify this a little bit. So I have log base 2, log 2 plus log x plus, so I have a squared, right? Bring that power up front. So plus 2 log y minus log of 5 minus log of, well, square root is just z to the half. Oh my god, there's another power, bring that out front. And finally, we're going to have the total answer. So there will be 5 terms. So log 2 plus log x plus 2 times log y minus log 5 minus 1/2 log z. And that's going to be it. Go ahead, try out the next problem, and then I'll show you the answer. Alright, I don't know why there was a star here. I did not mean to do that. Alright, anyway, so let's see. I have this top part, and then I have a bottom part. I can rewrite this bottom as 3 times x to the 1/4, y to the 1/4, z to the 1/4. All these are being multiplied together. That's why I originally had them all added in here. But then, since this is actually division, oh my god, I'm dividing, so therefore I have to minus all of the part that I had on the bottom. Okay, so the purple is showing you the distribution of the negative sign. The little green is showing you have to bring the product rule, you bring the, oh my god, the power. You're bringing the power out front of the ln, and then I have 5 distinct terms. Alright, and now we want to condense. So our goals end up with 1 log, right? We want 1 log at the end. We want to end up with 1 logarithm at the end. Okay. So first, let's bring this out front here. Alright, let's bring here. So that means these were the exponents, whatever number was out front. So this is going to be log 4 of x to the 1/2 minus, log base 4 of x minus 2 to the 3rd. The subtraction means division, so I have log, and notice it's both log base 4, so that's awesome. I can actually combine them. So log base 4 of, x to the 1/2 over, what I had on my right side, x minus 2 cubed. And then, of course, I can simplify this just a little bit, like rewrite it. All right, so that's the square root of x over x minus 2 cubed, and this is all log base 4. Okay, so awesome. I end up with 1 log. All right, let's try the next one. You can pause the video whenever if you want to try this out yourself. So I'm going to bring the coefficient, because that's going to be my exponent. So I have ln of x plus 1 to the 5th plus ln of x to the 6th. I have the same base, because remember ln is just log of e, base e. Alright, so since I'm adding, it's just going to be multiplied. So I have ln of x plus 1 to the 5th times x to the 6th. And that's it, because I'm literally going to be multiplying those together. Alright, and then change of base formula. This is probably the hardest part of this whole lesson. Just keep in mind you will have to memorize this. Alright. So log base b of x is equal to log base a of x over log base a of b. Okay, so keep in mind you will have to memorize the change of base formula, but this will be a calculator okay section because you're going to have to be evaluating logarithms. It's not exactly nice. Okay, so evaluate each logarithm. Wow, so I have a base of 6. Alright, so my base is 6. My x is equal to 4. It would be better if we would use like 10 for a, right? So that's a nice, easy number to use. Because right away you're like, okay, like 6 to what? Exponent equals 4. Clearly, 6 to the first is 6. Ugh, so it's going to be between 0 and 1. Like, what the heck? Ugh, this is not good. We don't know what this is going to be, but we know it's going to be a decimal. Okay, so clearly calculator has to be okay. Alright, so let's do the change of base formula. So log a of x, so log base, well, I'm going to use 10 for a, of x, which is 4, over log base A, well, A is 10, of 6. That's literally going to, well, let's see. Maybe I should have showed you the A and then tell you how I'm going to use 10, so that way I have log of 4 over log of 10, and that's easy. Plug it into your calculator and you will find the following. 0.602 over 0.778 gives you a little ratio, and we find it's about equal to 0.774. Because your calculator has, you know, log base 10 built in, and that's relatively simple. Okay, this one's a little harder. Give it a try. Give it a try. So let's list out. So I see my base is 4. My x value, I'm trying to, well, 4 to what power equals, this is like 4 to what power equals 4,212. What? I don't know. So let's see what power this actually is. Probably not an even one. Okay, and then we're going to use 10 as the base. It's just easiest to use 10. It's super simple. Alright, so I have log base A of, let's see, x over log base A of b. Well, that's 4. This is me. Let me use 10 as my base, so log of 4212 over log of 4. It's something nice. Your calculator will find this for you. So it's going to be 3.624 over 0.602. So that's around 6.02. Right, so it should have it actually equal. So it's about 6.02. Not too bad, not too bad. You just have to use your calculator and find it. You have to know the change of base formula, but it's not too bad. It's really log of the thing you want over log of base. Right, and that's it. So here's the assignment. Let me know if you have questions.